We're going to start on one of the most important topics here, and that's determining when f is increasing or decreasing, and that is based upon its derivative. And what do I mean by that? Well, if f prime is positive, if the slope is positive, then what this tells us is that f is increasing. Let me go ahead and get out Desmos so we can take a look at that. So you can see right here, look at the blue graph. You see how it's going up? As I go from left to right, it's going up. And if you look at the slope of the red line, it's positive. Let's take a look. Right here, right at the top, the slope is 0. That's a critical point. Remember that horizontal tangent there, the slope is 0. So that's a critical point. And that's why we're going to look for critical points in this assignment. And you'll see why in a little bit. And then right here, our slope is negative, and look what the blue graph is doing. The blue graph is decreasing, and it makes sense because the slope is the rate. If you have a positive rate, then the function's increasing. If you have a negative rate, then the function's decreasing. So if f prime of x is negative, and you're going to see me write this time and time again, then f is decreasing. Such an important thing. This is going to tell us so much more and just drive the rest of our or quite a few assignments after this, quite a few AP questions on this really important topic. So the main thing here is if f prime, not if f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. And remember, we saw this with velocity. When velocity was negative, our function was decreasing. When velocity was positive, our function was increasing. Same idea. So let's take a look at this. How are we going to determine the intervals in which it's increasing or decreasing? Well, we're going to start with not figuring out where it's positive or negative. Let's figure out where it's 0. That's where those possible changes are made. And you can see that when the derivative was 0 right here, that's when it made that change from positive to negative. It doesn't necessarily make a change, but if it does make a change, it's going to occur at the 0 or where it does not exist. In other words, those critical points. So let's start with the critical points. So we're going to call this the first derivative test. Really important test here. And it's not going away, I'm telling you. So find the critical points. So I'm going to start by finding f prime of x, which is 3x squared plus 6x minus 9. And we're going to set it equal to 0. We're finding the critical points, just like that last section. Let's factor out the 3. Continue to factor. And so the critical points are x equals negative 3 and 1. So second step, draw a number line. And what you're going to do, you don't want to put 0 on the number line. What we're going to do is we're going to use these values in numerical order. I'm just going to put the negative 3 and the 1. And we're going to test f prime. This number line represents f prime of x. Because if f prime, remember, if f prime is positive, f is increasing. If f prime is negative, f is decreasing. So remember, f prime of x, and that's our third step, we're going to test f prime of x. So what we're going to do is we're going to test it at values to the left of negative 3. We're not going to test it on negative 3 and 1 because we know if we substitute a negative 3 and a 1 into our derivative, we will get 0. That's not positive or negative. It just gives us 0. So we're going to substitute it in values other than these two values to see what sign we get. The only way we can change that sign from positive to negative is by reaching these zeros. So it's not going to change anywhere except for these two spots. So let's test a value to the left of -4. So these are x values. So when x is less than -3, let's think about a value. So our function f prime of x. So remember, f prime of x equals, let's use the factored form a little bit easier. I'm going to give us a little bit more room here. So we just need to know the signs. We just want to know, is f prime positive or negative? So think of a number less than -3. Well, -4. So we're talking about to the left of -3. So if I plug a -4 in here, I would get a negative. So I would get a negative. And if I plug a -4 in here, I would also get a negative. And negative times a negative is positive. So what does this tell me? That tells me that on this interval here, I'm going to get rid of this. You already know it's f prime. On this interval to the left of -3, our f prime is positive, which means f is increasing. Okay, what about between -3 and 1? So we don't have to use this number. If there was a negative in front, I would put that negative. But what's the number between -3 and 1? 0. 0 plus 3 is positive. 0 minus 1 is negative. Positive times a negative is negative. So it's negative on that interval. Then last, to the right of 1, if we plug in a number to the right of 1, 2. You can use 1.1. You can use a million if you want to. Point is, 2 plus 3 is positive. 2 minus 1 is also positive. So we'll get positive, positive, which is positive. So this tells us where f is increasing or decreasing. This is called the first derivative test. By the way, we're going to be using this test to also tell us other things. Then we're going to have a second derivative test. So all of this is really going to blow up, but really take it to this basic lesson here. If you get this down, you're going to do fine. So once again, this is the main idea. If your derivative is positive, f is increasing. I don't really like the way this blue looks right here. If the derivative is negative, f is decreasing. That's the main point here. So right here, we did the first derivative test. We found the derivative. We substituted in to figure out the sign of the derivative. The derivative is positive here. It's 0 at -3. It's negative here and 0 at 1. And then it's positive again here. So if the derivative is positive, f is increasing. So when is f increasing? Well, that would be... I made this purple. I'm getting so picky. So that would be to the left of -3. Let's see if that's an option here. X is less than -3. And x is greater than 1. Yeah, those two places is where our function's increasing. That's where f is increasing. Why? Because f prime is positive. By the way, when you do free response in the AP test, that's your reasoning. That's all you have to put. When they say explain why f is increasing, you just have to say f is increasing and x is -3 and x is greater than 1. Why? Because f prime is positive. That's it. That's all you got to say. You don't have to get all fancy with it. This one's a very similar problem. Let's go over one of these. These have the same idea. So we're going to go through those same set of steps. This time they don't give us what f is. We already have the derivative. So we're going to start by finding the critical point. So first, critical points. So we already have the derivative, so the hard work's been done for us. So there's possible changes at these critical points. So the critical points are at x equals 2. That's where the derivative is 0 because the top is 0. But also the derivative is undefined. It doesn't exist at -3. So those are the two places. So number 2, the number line. So numerical order, where -3 is to the left of 2. Don't put a 0. We just want those values on there. And there could be more values. It's not always 2. Just these two examples only have 2 critical points. And then last, we're going to test g prime of x. So g prime of x is x minus 2 over x plus 3 squared. So to the left of negative 3, it would be negative 4, right? So if we were testing this one, on the top, negative 4 minus 2, that's negative, right? Then on the bottom, it's going to be squared. So isn't the bottom always going to be positive? And a negative divided by a positive is negative. Let's try between negative 3 and negative 2. So on a number between negative 3 and not negative 2, positive 2. My bad. A number between those would be 0. So if I plug a 0 in there, I get a negative on the top and then also a positive, because no matter what on the bottom, it's going to be positive because it's squared. Negative or positive is negative. Notice the critical points mean there's a possible change, doesn't guarantee a change. So here at negative 3, there was no change. Now remember, x plus 3 being squared might have something to do with that. You know, anytime something squared is positive, that might be the reason we didn't have the change. Something to think about as you go through these problems. Last, we have x is greater than 2. So what's the number greater than 2? Let's go with 3. 3 minus 2 is positive over 3 plus 3, while being squared, is also positive no matter what. So we get a positive in that interval. Let's see what this question asks for. On what intervals is it decreasing? Now, there's two different types of decreasing. Strictly decreasing means the derivative will never be 0. It means that entire time it's 0. And then there's monotonously increasing or decreasing. That means as long as the derivative is negative or 0. So if it's 0, it still gets counted in that interval. And I think the way Khan, unless they fixed it, they were sticking to that last one I was talking about. But let's take a look. Negative 3 to 2, not just that. I think everything to the left of 2, if that's an option. So x is less than negative 3 and between negative 3 and 2. And I think Khan fixed that because technically it's not decreasing at negative 3. They used to include that whole interval. Looks like they fixed that though. But at negative 3, technically it's the derivative is 0, so we're not increasing or decreasing. Remember, like I said, there's two different categories of that, but I think for AP, for us, we're counting this as not increasing at that spot because the derivative is 0, which makes more sense. We're talking more about the strictly decreasing or strictly increasing. So anyways, that would be the answer. You want to split those up. Khan did fix that. They didn't have it fixed before. And that's it. That's where it's decreasing. That's the idea of the first derivative test. So have fun with that. Honestly, really get that down. That's a very, very important part of the class. And I hope this video helps. I mean, I went through that in quite a bit of detail. And we're going to be using this to tell our maximum and minimums and really a lot of the future assignments, relative extrema, absolute extrema, concavity, all that stuff we're going to be using this test on. So